it's good to be here again. Hmm? I want to remind you of something very important. And what is that? I'm going to walk you through prime factorization. I said I'm going to be walking us through what? Prime factorization. But I'm using the word prime. Of course, you must have heard of prime numbers. Prime numbers, right? Is that true?
Yeah.
Prime numbers and prime factors, right? Prime numbers and prime factors. But a prime number, if you can see, there's something for us to recall. Very important. What a prime number is. And here, if you look at the board, it's clear that a prime number is a number with only two factors. A number with only two factors. And what are the factors that you will see in any prime number? You will see the number 1 and whatever that prime number is. So there are only two factors, 1 and the number itself. Is that okay?
Yeah.
So we have to take note of this. That's why I am underlining it. And what have I said? I've said that a prime number is a number with only two factors. Do you get that? So if a prime number is a number with only two factors, what then is a factor? When I say get the factors of this number, get the factors of that number, what I'm simply asking you to do is to get a number that can divide the number you're looking at exactly without a remainder. So we're saying that a factor is a number that can divide another number exactly without a remainder. So for a number to be prime means it has only two factors. Do you understand that? So if you recall, I mentioned some numbers. I said 2. Look at the number 2. 2 is a prime number because the factors of 2 will just have 1 and 2 itself, right? I also said 3 is a prime number, 1 and the number itself, 3, right? 5 is a prime number, 1 and 5. 7 is 1 and 7 as examples of what? Prime numbers. Thank you. And if you notice here, these 3, 5, and 7. Hello? 3, 5, and 7 are all odd numbers. They are all what? Odd numbers. The only even number that is a prime number is 2. Apart from the number 2 as an even number, every other even number is a composite word number. Remember I told you that if a number is not prime, it is composite. And if a number is composite, it means that it has more than two factors. Well, if there are just two factors only, that number becomes a prime number. It becomes what? A prime number. So, we cannot be talking about prime factorization without taking us down memory lane to remember what prime numbers are so that we can easily identify the prime numbers, right? Yeah. So once more, it is clear, look at the board, it is clearly written that a prime number is a number with only two factors, 1 and the number itself. If you look this way, you will find out that for number 2 here, the only factors of 2 are numbers 1 and 2. The only factors of 3, number 1 and 3. The only factors of 5, 1 and 5. The only factors of 7, 1 and 7. Right? Good. Please take note. And also remember I told you that 9 is not a prime number. The number 9 is not a prime number. The reason 9 is not a prime number because it has more than two factors. 1 is a factor of 9, 3 is a factor of 9, 9 is a factor of itself. Though 9 is an odd number. So we concluded by saying that not all odd numbers are prime numbers. Do you remember that? The fact that a number is odd doesn't automatically translate that that number is a prime number. Please be on the lookout for this. Not all odd numbers are prime numbers, right? But all prime numbers, apart from 2, are odd numbers. With the exception of the even number 2, every other prime number is an odd number, but not all odd numbers are prime numbers. Alright, it is important that we learn how to express numbers as products of their prime factors, because we will actually use numbers in this form to get the HCF and LCM of whole numbers. I told you already that the reason it's important we learn about this prime factorization and learning how numbers are left in index form, how to leave numbers in index form, will aid us when we see numbers in their index form and we want to look for the HCF or the LCM of numbers like that. But look at this. There is a question here. Haven't remembered or recalled the definition of prime number, saying that a prime number is a number with only 2 factors, 1 and the number itself. Well, the instruction here is to express the following as product of its prime factor. That's not the only instruction. They went further to say that we should leave our answer in what form? In index form, not in ordinary form this time around. So look at this. To express this, I'm going to use the tree method. Of course, I'm going to use the tree method. So if this is 144, this is 144, I want to express as a product of its prime factor. I'm going to just ask myself, I'll come this way. I'm going to ask myself a very simple question. What 2 numbers that must be multiplied to get 144? Of course, I can think of 72 times what? Okay, I can think of 12 times 12 as well. That's fine. I can work with 72 times 2 or 12 times 12. Okay, let's work with what? 72 times what? 2. Is that okay? Working with 72 times 2, let's work with 72 times 2. Alright, look at this. This is a prime number. Once I get a prime number, I just circle the prime number for you to show that I've gotten to where I'm going to for this. But look at this 72. 72 is a composite number. And because it is a composite number, I cannot circle. Since I cannot circle, I have to look for 2 numbers that must be multiplied to give me 72. And what are those 2 numbers? What 2 numbers will be multiplied to get 72? Are you thinking of any? Is that true? 36 times 2. If you look closely, you will see that 36 times 2. 36 times 2 is what? What's 36 times 2? 72. This is a prime number, right? Remember, 2 is a prime number here. Alright, I'll still come this way. I still have 36. And what do I have here? I'll keep going. This is 2 times what will give me 36? 2 times what? 2 times 18, right? Okay. This is 2. I'm going to circle 2, right? And now for 18, I have what? 3 times 6, right? To be 18. This is a prime number, right? And for 6, this is what? 2 times what? 3. Prime number, prime number. Is that true? Alright. If you observe here, I've just been breaking it down via multiplication and circling all the prime numbers that I have. Can we identify the prime numbers so far circled? We have 2 here. 1, 2, 3, 4. So I can see 2 appearing in how many places? 4 places. So that this is 2 times 2 times 2 times 2. Right? And how many 3's do we have there? 2, right? So this is times 3 times 3. Is that right? Alright, but the instruction says that we should leave our answer in index form. Please remember, remember, 2 times 2 times 2 times 2 times 3 times 3 is this number in the ordinary form. And this is looking very cumbersome. But let's make life easier for ourselves. How many times are we seeing 2 here? 2 is appearing how many times? 4 times. So we have 2 to be our base now. So say PF of 144 is, this is 2 to power 4 times 3 to power 2. You can see that this 2 to power 4 is the same thing as saying 2 times 2 times 2 times 2, right? And 3 to power 2 is the same thing as saying 3 times 3. So if I say 2 raised to power 4 times 3 raised to power 2, it's the same thing as the other person who is writing 2 times 2 times 2 times 2 times 3 times 3. Just that while this is in the ordinary form, this is in the what? Index form. It is very, very important that we take note of that. So this is the prime factorization using the 3 methods. This is not the only way, or this is not the only method of carrying out this prime factorization. But for the purpose of convenience, I think we're going to work with this. But if you want to see the other method, or you want us to remind ourselves of the other method, you can as well go down memory lane to get it out from you. Alright, okay, that's fine. But you have to take note of this. Remember, this is a reminder. This is to bring back to your mind. Bring back to your mind what you should know already. Is that okay? Yeah. Alright. Okay, the next. Here we have 200. We are also going to do the same thing. We're going to express 200 as what? Product of its prime factor. 200. I'm expressing 200 now as product of its prime factor. Exactly what I did with 144 is what I will do for 200. And what is that? What is that? It is very simple. I'm going to think of 2 numbers. 2 numbers that must be multiplied to get times 100 times 2. I appreciate that. 100 times 2 is 200. Thank you so much. So this is 2 times 100. 2 here is a prime number. So 2 will just be cooling for us here, right? It will be cooling. Alright, so once you get any prime number, you allow it to cool. You allow it to cool down. We don't send it home. You just have to cool down. Alright. So I have 100 here. Because 100 is a composite and not a prime number, I'll still need to break it down. And what do I do? Look for 2 numbers that must be multiplied. Get 100. Oh, thank you. Alright. So this is 2 and this is 50. This is another prime number that we'll have to cool down and wait for us, right? We're going to work with it. So let's break down 50. 50 is a composite number. Okay, thank you. 5 times 10, prime number, right? Alright, and for the 10 composite, we have to break down. Alright, thank you. Prime. Is that true? Yes, these are. So the numbers we have circled, are the prime numbers. The numbers we have circled are the prime numbers. Remember, the question is to express 200 as product of its prime factors. So we're interested in the prime numbers. But mind you, 2 raised to the power 3 times 5 raised to the power 2, right? Thank you so much if you're leaving your answer in index form. But mind you, all the numbers we're bringing out are factors of 200. 2 is a factor of 200. 5 is also a factor of 200. But what is special about these numbers is that they are not just ordinary factors. All these numbers that are factors are at the same time prime numbers. That's where prime factors is coming from. Do you understand that? So they are prime factors. They are not just ordinary numbers. All the numbers there are prime numbers. And at the same time, they can be used to divide 200 exactly without a remainder. That is why we call them prime factors. Are we together? Alright, that's a good one. So I'm going to get out all the prime numbers that are cooling for us. They will have to come out now. So PF, this is 2 times 2 times 2. So I have 1, 2, 3. 2 here. Then this is what? Times 5 times 5. In index form, like you said, 2 raised to power 3 times 5 raised to power 2 is what? 200. What's 2 raised to power 3? 2 raised to power 3 is what? So what's the answer? 2 raised to power 3 is what? 2 raised to power 3. 2 times 2 times 2. So 2 times 2 times 2 is what? What is 2 times 2 times 2? Yes. 2 times 2 times 2. Not 2 plus 2 plus 2. Common mistakes students make. Yeah? When you tell them 2 raised to power 3, they will go and do 2 plus 2 plus 2, get 6 and fail. They say, well, Miss Ruth, you said I didn't say anything. Look at what I'm saying. 2 raised to power 3 means 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. Right? Alright. So we have to take note of that. And 8 times 25 or 25 times 8 is 200. So it is very important, very, 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 very important that we take note of the prime factorization method. Why we are leaving our answers in index form is in case you are asked to find the HCF. Somebody can ask you to find the HCF of 444, 200 and 175. But the person might not write 144, 200 and 175. The person will give you the prime factorization of this same number in the index form and ask you to find the HCF. As we progress, we are going to look at how to use numbers in their index form to get HCF or whatever we are looking for. It's even easier to use this factorization method to look for HCF than the regular or random method we know. Okay, please let's look at this. This is the third and the final is the final one I'm going to work out for today, and that is 175. We have to express 175 as a product of its prime factor, and we will at the same time leave our answer in index form. I said at the same time we're going to leave our answer in index form. Very important. We are going to leave our answer in index form. Express 175 as a product of its prime factor. Are we together? Yeah. Alright, that's fine. Okay, let's look this way. So this is 175 as usual. Can we think of two numbers that must be multiplied? 5 times what? Yes. 5 times 35. Okay, so this is times 35. So it means 35 times 5 is what? 35 times 5 is what? 175. Is it not true? 35 times 5 is 175. 5 is a prime number, true or false? Okay, because 5 is a prime number. See what I'm going to do? I'll just circle 5. 35, what will work here for 35? What times what will give me 35? 5 times what? 5 times 7. Prime number, prime number. Is that not true? So this is PF of 175 should be 5 times 5 times 7, which is something as saying 5 raised to power 2 times 7. Please, this is 5 raised to power 2 times 7. My answer in index form. It is very important, very, very important that we take note of this prime factorization, because, like I said, we are used to the normal method of looking for HCF, where they say find the HCF for 40 and 50. You now say, oh, what are all the factors of 40? What are all the factors of 50? What are the common factors? And what then is the highest common factor? That is the method we're used to. But for numbers that are very large, for bigger numbers, it is fine we express as product of its prime factor, leave in index form, and look for the HCF. It's easier for us that way. That is why at this elementary level we are, it is important we learn how to leave numbers in what? Their index form. As we also progress in the knowledge of maths, you're going to learn how to identify numbers in standard form. So we have numbers in index form. Of course, when you have more than one, that will be indices. So we have numbers in index form. We also have numbers in standard form. You will learn how to work with numbers in index form. You also learn how to work with numbers in standard form. When we get to standard form, you identify how to convert a whole number, to write a whole number in standard form, a decimal number in standard form, to add, divide, multiply, and subtract numbers in standard form as well. So there's a lot to do. There are lots of interesting things to learn in the various topics at the elementary level of mathematics. So thank you so much. Well, you're going to take this down neatly, take it down as a way to remind yourself of what we have done, and you will get some assignments, and I'm going to test your knowledge on what we have done as well.